This is the last video related, not the last, this is the last example problem related to the chapter solutions. Certainly it's not the last video. And we're talking about example 2.11, and this is related to the osmotic pressure being one of the colligative properties and calculation of the molar mass of the solute using the osmotic pressure. So 200 centimeter cube. Actually, didn't we change it the last time? Let's do it that way. 200 centimeter cube of an aqueous solution of a protein consists of 1.26 grams of the protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. We need to calculate the molar mass of the protein. So we have been given the value of the volume. So the volume of the solution, my handwriting looks so bad. So volume is equal, that is V equals to 200 centimeter cube. And this we can convert it to liters. And the reason we want to convert it to liters is because the equation we are going to be using is M2 equals to W2 RT divided by pi into V, where W2 is the mass of the protein, R is going to be the universal gas constant, and R is equal to 0.083 liters bar per Kelvin per mole. So this is the value of R, and since it's in liters, we want our volume to also be in liters because we want our units to be taken care of. So basically, we are actually, no, I'm sorry. This is not the last example problem. There is another one. Just realized. This is the last one related to colligative properties. So this 200 centimeter cube can be converted to liters to give us 0. It's divided by 1000. So 0.200 liters. Okay, because that's again one of the things that we learned in the previous chapter related to basically 1 centimeter cube is equal to 1 ml, and 1 ml getting converted to liters is done by dividing it by 1000. Okay, so this essentially is 200 ml. This divided by 1000 will give us the value of volume in liters. So this is the volume. The next one we have is the mass of the protein. So W2 is equal to 1.26 grams. We've been given the value of temperature, that is T, that is 300 Kelvin. The last one is the value of pi, that's the osmotic pressure of the solution, that is 2.57 into 10 to the power minus 3 bar. So we are going to be substituting all of these values in this equation. So M2 will be equal to W2, which is 1.26 grams into R, which is 0.083 liters bar per Kelvin per mole into temperature, that is 300 Kelvin whole divided by, oh my god, let's control set that. Okay. So whole divided by the pi, that is the osmotic pressure, 2.57 into 10 to the power minus 3 bar into the volume 0.200 liters. So bar gets cancelled, liter gets cancelled. We need gram, obviously. per Kelvin, and Kelvin gets cancelled. So we'll be left with grams per mole, which is exactly what we want. So we get, when we simplify the numerator, we are going to be getting 31.374 31.374 divided by 0.514 into 10 to the power minus 3 grams per mole. Now we're going to bring this to the numerator. So we get 31,374 divided by 0.514 grams per mole. And this is going to give us the value of 61038.9 grams per mole. Excuse me. And I know that the answer given in your textbook is slightly different. They've given 61022. When you simplify all of these values to get this final value, this is the answer that is obtained. So yeah. So basically, we just substituted. The only thing about this question is the fact that we had to convert our volume from centimeter cube to liter. Remember, centimeter cube is equal to 200 centimeter cube is equal to 200 ml. So we were able to convert that by dividing it with 1000. And then we just substituted all of these values to give us the value of molarity. Again, if you had not converted it, I'm pretty sure when you had come here, when you looked at the units, you would have been able to identify that you had to do that in the first place. I hope this helps. With that, we're done with the example problem. We'll be doing the last one in the next video.